problem is that a rectangle is to be inscribed under the arc of this curve. And so the curve, f of x right here, has this equation right here. And it goes from x, the rectangle goes from negative pi, negative pi, which is over here, to pi, which is over there. Are we okay with that? And I'm inscribing a rectangle inside of that curve, and I wrote that the rectangle that I drew is not necessarily the one that we're looking for, but I just want you to be able to visualize how to set up the picture. That's all right? Okay. All right. So we want to find the maximum area of the rectangle, and we want to find the dimensions of the rectangle. So I was trying to kind of, so I think from reading the problem, if we find the area, we can find the dimensions. Does that make some sense? Okay. So, because I'm trying to find, I have to find the maximum area. That's what I'm looking to find here, is the maximum area. So that's telling me that I need to have an equation for the area of this rectangle. If I have an equation for the area of the rectangle, then I'll be able to take the derivative and find what the minimum and maximum are. Does that make sense? Okay, so I'm just trying to help you visualize how to set up the problem here. It's telling me I got to find the maximum area of the rectangle, and then I can find the dimensions. So the first question that I ask here is, what are the coordinates of the point P right there in terms of x? Does anybody want to volunteer an answer? Well, I already gave you half of the coordinates. I said this is point P and it's x. What's the y value? Well, f of x, that's exactly right. And what is f of x? It's right there. It's 4 cosine 0.5x. So this is the, I mean, it's like right there in front of your face, right? X, comma, 4 cosine 0.5x. Now, I just want to make an observation here. This is like directly from the book, directly from the practice problems that I recommended that you do. Okay, so does that make sense? Right? Okay. So we all know that the area of a rectangle is base times height. Correct? Area of a rectangle, base times height. Okay, so let's go to the next one here. So it says, what is the area of the rectangle in terms of x? That is, what is the equation that's going to allow you to calculate the area? Well, area equals base, here's my base, times my height. Well, what's my base? My base is 2x, right? Because I got to go from here to there, and there to there, yes? And what's my height? 4 cosine 0.5x, yeah? Okay, so now I have my area is equal to my base, which is 2x, times 4 cosine 0.5x. There's my area. Everybody knows how to do this problem right now, right? What? You feel defeated? Don't feel defeated. Don't feel defeated. There's a ratchet quiz. No, okay, right? So let's just kind of simplify it just a little. Yes, please.
Okay, I don't know if this is right, but the way I would rather define what like f of x is, I did like, I saw that for x, like pi over 2 plus another distance was the full length of x. So I
So you called this little segment right here A, right? And over here you called it A, right? So you said A plus pi over 2 was the x value, and then you took that and put it in right there for x. I'm thinking. So my question is, what did you have for the area? What was your formula for the area then?
For number 2.
Yeah.
A equals 2 times A plus pi over 2 times 4. Times 4 cosine 0.5A plus 0.79.
Plus what?
0.79.
Oh, A plus pi over 2?
Yeah, I did 0.5 times pi over 2. Yes.
I know. Let's put that on hold. Okay, let's put that on hold. It might work, but I'm not sure. Okay, is that okay with everybody? Okay. So, because I'm 90% sure that I'm more than 90% sure. I'm really sure that that's the area of the that is a function that gives us the area of the triangle, of the rectangle. Yes. Okay. So let's just change it here, and we'll call it 8x, because of the 4 times the 2, 8x cosine 0.5x. That's my area. Okay, and that's all I'm asking for. What is the area of the rectangle in terms of x? That is the answer so far. Okay, so let me take that, copy it. Okay, now it says, what is the equation you will need in order to find the maximum area of the inscribed rectangle? So what do we need to do? What equation are we going to need to find the maximum area? Yeah. Nope. The derivative of that, right? The derivative of that equal to 0. Okay? So I'm looking at this. I see a product. 8x times cosine 0.5x. Right? So I'm going to take the derivative with respect to x of that, and the derivative with respect to x of that. And so I'm going to pull my constant through the derivative so I don't have to worry about it. So I have 8 times the derivative with respect to x of x cosine 0.5x. So u v, so I have 8 times, see, I go u v plus u v prime prime. So I got u prime, I got 1 times cosine 0.5x plus x, and what's the derivative of cosine? Negative sign, isn't that right? Okay, plus, so that would, so, okay, I'm going to x times negative sine 0.5x times the derivative of the inside. 0.5 times 0.5. Right. U prime v, yes, u, then v prime is negative sine 0.5x times the derivative of the inside, which is 0.5. Am I going okay so far? I think so. Okay. So I have 8 times cosine 0.5x minus. I'm going to just make this a minus sign. Minus 0.5 sine 0.5 x. I just moved this 0.5 into the front. I'm missing an x, right? Yes, I'm missing that x right there. I don't like this. I don't like the way that looks. It's too confusing. Okay, so I have the minus x sine 0.5 x times 0.5. That looks a little bit better. Am I still okay? I think so. Okay. All right. So I'm going to distribute my 8. I mean, really, if you got that far, I'm fine with it. But I'm going to distribute the 8, so I have 8 cosine 0.5x. This is, now remember, this is for a prime. This is the derivative of the area. 8 cosine 0.5x minus, well, now the 8 times the 0.5 is going to give me 4. Yes? Are we okay with that? This is one term, x sine 0.5x 0.5. So if I distribute this 8, I can knock out this 0.5 here and make it a 4. So 4x sine 0.5x. And I think that's about the easiest way to read the derivative of the area. Okay? What do I do now? Yes. Yes, please. Okay, here's the original area. Why do I have to pull the 8 through the derivative? Because the 8 applies to not just the x, it also applies to the cosine 0.5x, right? Is it right? I mean, so really this is the same as if my function was a times b times c, right? I'd actually have to do u v z. You know, so I'd have u v z plus u v z plus u v z, you know, prime, 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 to solve this product if I was taking the derivative. Are you okay with that? Right? But it's much easier if I just pull that a through the derivative, then I only have to deal with 2. Okay, because this, the derivative, if that a is a constant, I know that u prime is going to be a 0, right? So I don't really need that at all because that's just going to be 0. And then I have 8 times that and 8 times that. So I just pull it through. Still okay? Yes? Okay. All right, so let's, again, what am I going to do? What? I will in a minute, but before I do that, I got to do something else. I got to graph it, right? Because I might have made a mistake, right? So let's, all right, somebody's going to have to read this to me because I don't have 2 screens. I like it. I like 2 screens. All right, so area with respect to x. What's the area formula? 8x. We'll go times cosine 0.5x. Okay, there. Ooh, look at that. Wow. All right, and let's just call it b of x, my derivative. What do I have for my derivative? 8 cosine 0.5x minus 4x sine 0.5x, 0.5x. Okay, so that's my derivative, and let's just go c of x equals e to dx a of x. And is it the same? Indeed it is. It's the same. Okay, so I got the derivative going along okay. Pretty good? All right. So the next step was use your calculator to solve it, because I didn't want you to solve that problem. Let's write it up here. Let's write the derivative here. So here is my derivative right here. Control C. And if I go here and I go Control paste, okay. Honestly, I don't know what value of x is gonna make that equal to 0, right? Because it's not. I mean, maybe I could figure it out, but I didn't really think it was necessary to do that. I wanted you to get this far, right? Yes. Well, so you just said a minute ago, Jocelyn, that I need to set this equal to 0, don't I? Okay, well, so I'm going back to my Desmos here. And I want to look at my derivative. Well, so I have, I know that my function only goes from negative pi to positive pi. Is everybody okay with that? Okay, so I'm just going to set it here. I'm going to say this is going from negative pi to positive pi. And whoops, I'll make my steps in pi over 2. Okay, so I see I have 2 zeros. I have a 0 there at negative 17.21 and a 0 here at positive 17.21. Yeah, that's right, 1.71. That number there, right? Right. So are those my 2 answers?
No.
Why not? Because I can't have a negative distance, right? I can't have x be a negative, right? You everybody okay with that? What I'm saying here? Stop me. No, we're good? Right? Okay, so I know now that x is equal to 17.21. So x is equal to 1.721. And now to go back to my problem, I want to find the maximum area. Okay, well, I have a formula for the area. The area is that right there, isn't it? So I think I'll just go back to Desmos here, and I'll look at Desmos, and I'll say I would like A, well, no, I mean, it needs to be a capital, so capital A of 1.721, and it tells me it's 8.98. Gives me the answer right there? Yes? So my x, so let's see, so that would be my y value is 8.98. So I go back to my picture of the rectangle here, and I know that this distance here, no, I made a mistake. Yes. This distance here is 1.721. I'm clear on that, right? And my base is that times 2, so that would be 3.442. My entire base is 3.442. I add them together, right? Okay. I still need my height. Right? Because I'm getting the dimensions of the rectangle. How do I find my height? Into what? Nope, area function, I just did that, and that gave me this 8.98. This is the area. You know, you can't see that on the screen, right? You could do that, but there's an easier way. So we did the area of with x equal to 17.21, and we get 8.998. So the area, let's go back here. The area here is 8.98. Come on now. How do I get the height? Even easier. Right? Right? That's my, right? Right. So 4 cosine 0.5x. Let's just do that here. Again, we can do it on Desmos. 4 cosine 0.5 times 1.721. It gives me 2.61, and that's my height, 2.61. So I'll come back here, and this point right here is really 1.721, 2.61. So those are the dimensions. Then would be 3.442 for the base, and 1.721 for the height. Go ahead, you're on.
When you like, because the 1.71 is just for half the rectangle. So how, like, I get that you plug it into the area and you get 8.9, but wouldn't that just be for half of the rectangle?
Well, that's an interesting question. Let's try. So the question is, you know what? Let me do this. Let me just let me clone this page, and let's just clear the ink off of this here so we can see it more clearly. So we were looking at, this is x, right? And then this is our half of our base, but this is our height. But remember, when we defined the area, we defined the area as 2x times the height. So that took care of both of them. So if my x is 1.721, then my base is going to be twice that. And then the area, since I define the area as 2x, no, it's not just going to be this area here, it's going to be the whole area there.
So when you plug in 3.442 into the area equation to get, like,
well, so let's think it through. I could definitely be wrong, but I don't think I am. But let's see. So if my area is equal to 2x times cosine 0.5x, right? This is my base. That's my height, right? If I plug into here the 3.44, then I'm going to be, if I plug into here the 3.44, then I'm going to be doubling the size of the base, and I'm actually even going to be going beyond, you know, pi and negative pi and pi. Yeah, make sense? Yes.
can you explain how you got the height?
How I got the height? Yeah, because the function tells me that the red part right here, which I'm now making green, that's the function, f of x right there, yes? Okay, so I'm gonna ask you a separate question here. What's my favorite function? And my favorite function is x squared. Okay. This is f of x equals x squared, right? Okay, here is the point 3. What's the value of that point right there? What are the coordinates of that point? 3, 9. How did you know that? So you took the 3 right here, and you put it into the x squared, right? Well, my function isn't x squared. my function, too many buttons. My function is 4 cosine 0.5x. So if I have an x right there, that point right there is going to be x 3 9. But instead of it's going to be x plugged into this right here.
I thought when you plugged it in to the equation, you got the whole area. Like if you put it into Desmos, a times a of x, and then you plugged in for x 1.721, and then you said, oh, that's the whole area. But I thought that was the y value, the height.
No, the one okay. The oh no wait. Am I messing up here? I can.
Yeah, like when you plugged in, you put a of 1.721, and then you were like, okay, that's the height, and you're like, wait, I made a mistake. No, it's actually the whole area height. Like that didn't make sense to me how it's the whole area.
Okay, let me think back through what I'm doing here. All right, so my area. Okay. This point right here is the point x, comma, 4 cosine 0.5 x. You're okay with that, right? Okay. So my area, if this distance right here is x, and my entire base then is 2x. You still with me, right? So my base equals 2x, and my height equals 4 cosine 0.5x. Height equals 4 cosine 0.5 x. All right. So are we in agreement that the area of the triangle, of the rectangle, is 2x times 4 cosine 0.5 x? This is the equation for the area of the rectangle. Okay?
Yeah.
Okay.
Oh, I get it. I was messing up. I was like thinking a of x and f of x is the same equation.
Different equations. You good? Okay. Everybody good?